One purpose of derivatives is to analyze functions and what their graphs look like. Now, one thing we're going to do today is look at the extreme values of functions and how we can find those. So first let's figure out what that means. An absolute or a global extreme is the maximum or minimum function value that there is for the whole function. So it's the biggest or the smallest value for the whole function. Now most of the time we're going to look at local or relative extremes. Now what that means is that it's the maximum or minimum function value that there is for a certain interval of the function. So if we have a graph, let's say it looks like this. Okay, this will be a local max or relative max. This would be a local min. This would be an absolute max. It also is a local one. And this would be an absolute minimum. Now, one thing we need to look at with these is what happens with the derivatives along these. Well, if you notice a derivative, remember that's the slope of the tangent line. If you draw in the tangent lines at these maximum and minimum values, what do you notice here for these? Well, you notice that the derivative is equal to 0 at these maximum and minimum value lines. Now, let's look a little bit at the derivatives around there. What do we know about these derivatives? If we draw in some tangent lines in here, all these slopes on this side are positive. But what happens on this side? Right, they're all negative. So for a maximum, you're going to have positive on one side of it and the negative on the other side for the derivative. And then for a minimum, we've got all these negative slopes, and then what happens? They switch to positive slopes. So for a minimum, we'll have negative derivatives, and then at the minimum it's 0, and then positive derivatives around it. So we're going to use that information to be able to find the maximums and minimums. So we've got a theorem that will help us with these. It's called the extreme value theorem. And what it says that is that if f is continuous on a closed interval a, b, remember that means that a and b are included in that, then f has both a maximum and a minimum on that interval. Now you may be thinking to yourself, what about if we have like a line or something like that? Well, if we put it on our interval from A to B, then you'll notice here at A we have a maximum, and here at B we have a minimum. So the maximum or minimum could be at the endpoints. So what we end up with is something called critical values. That's where you're going to look for your extreme values, because I'm sure you realize that every time the derivative is equal to 0, that doesn't mean it's a maximum. We could have a line that goes like this, and here the derivative is equal to 0, but there's no maximum or minimum point there. So the critical values are the places where we're going to look to see if we have a minimum or a maximum there. So we just discovered that we need to look at the endpoints. We talked about that we need to look at when the derivative is equal to 0. And then the other time we need to look is when the derivative is undefined. Because, for example, in an absolute value function, we may not be able to find the derivative there, but that's clearly a minimum point. So our critical values are at the endpoints, when the derivative is 0, and when the derivative is undefined. And that will tell us where we look for our extreme values. So let's try one. Okay, so if we've got this function, y equals x cubed minus 2x plus 4, that's a polynomial function, then the first thing we want to do is find the derivative, because the derivative is going to tell us where we're looking, because we're not looking on an interval here, so there's no endpoints to look at. So we just need to find the derivative to see where it's undefined and where it's equal to 0. So we'll write that. There's no endpoints to look at. Okay, so the derivative is 3x squared minus 2. So next we're going to find the critical points. And as we said, there's no endpoints, so we don't have those to look at. So we need to look at when the derivative is equal to 0 or the derivative is undefined. So let's look over here. Now, when it's equal to 0, we can solve this. We get x is equal to plus or minus the square root of 2/3. Okay, that's approximately 0.8165. Now, the thing about these is it's usually easier to just leave it in the square root form, but what we're going to do in just a minute, you'll see why we need the decimal approximation. So we look at that, that's when it's equal to 0. It's defined everywhere because it's just a polynomial, so there's no places where it's undefined. So these are our only critical points. Now, there's a couple of ways you can test whether they're maximums or minimums. The first method is you can plug it into the function and see which one's bigger. The second method is to test with the first derivative. I prefer that one because it's easier. So the way we do that is you just make yourself a little chart here and put your values on it. So this is the square root of 2/3, just like a number line. That's what you're making, is a little number line. So we've got the positive square root of 2/3, which is approximately 0.8165, and the negative square root of 2/3, which is approximately negative 0.8165. So what we're doing is we're going to test these intervals, because what did we say about the derivative, the sign of the derivative, as we're getting to these maximums and minimums? If we can tell the sign of the derivative, then we know which way the function is going, so that we'll be able to tell these maximums or minimums. So here we just need to pick a value in between. Well, 0 is in between, so that's pretty easy. Plug it into the derivative, and we see we get negative 2. Now we don't need the exact value. We just need to know if it's positive or negative. So we just plug that in. Now we need to look here. This is why we need that decimal approximation. It's approximately negative 0.8, so negative 1 would be down here. So if we plug in negative 1 here, we're going to get 3 minus 2, which is 1, so that's positive here. And then over here we can plug in positive 1, because that's just a little bigger. You just pick an easy value that fits in this interval on the number line. So 1 is easy, 3 minus 2 again is positive. So what this tells us is our function looks like this and then like this because it's negative over here and positive over here, 0 there, and this one's going like this and then this, which means that this is a maximum and this is a minimum. Now, if you're asking to find the extreme values, you're going to want your answers to be the points, so you're going to have to plug those in and get the actual point, or if they're just asking for the x values, then you would just have these x values, and you would say there's a maximum at x equals the square root of the negative square root of 2/3, and there's a minimum at the square root of 2/3. So when you're finding your extreme values, first you look at your critical points. Find your critical points. So our critical points are, we need to find the derivative so we can do that. And our critical points are at the endpoints where the derivative equals 0 and where the derivative is undefined. So we do all that to get our critical points. Then we have to test our critical points to see if they are indeed a maximum, a minimum, or neither. So you can plug it into the function if you want, but the better way to do it is to test the first derivative so that you know what's going on. The other thing you can do is, of course, graph it and look at it. You can graph it on your calculator. But you definitely need to know how to do this first derivative test. It's really important. So we look at the signs and what that tells us about how the function's moving. This positive means the function is increasing, it's getting bigger. And this means the function is decreasing when the derivative is negative. So find those critical points, test them to see if they are extreme values. Make sure you've got notes, make sure you've read the section for 4.1 and written down any questions that you have.